Hello everyone, and today we have a video about the Stirling numbers of the second kind. The Stirling numbers of the second kind is a short way that I think the name of the guy, Stirling, made to find the shortcut of putting the balls in the box. So today I will show you guys some of the part of this graph I made. And K means box and N stands for ball. And ball is distinguishable and box is indistinguishable. Distinguishable means different and does not. And at least one ball has to be in the box. So let's start this. Okay, so if we have 0 box, there's no box, and there is 0 balls, how many ways can we put that? That is actually 1. I don't know why, but I think there was too many arguments and they just said that it was 1. And let's start this one. So we have 1 box and no ball. How many ways can we put there? That's just 0. And it would be the same again if we have 2 boxes, 0 balls. So this is 0, and this is 0, this is 0, this is 0, this is 0. This is also 0, and this is also a 0. And now we have 0 boxes, and we have 1 ball. How many ways can we put that in there? That is equal to 0. Okay, and now we have 1 box and 1 ball. How many ways can we put that in there? That's just equal to 1, right? There's 1 ball, 1 box, there's 1 way to put it in. Okay, and now we have 2 boxes and 1 ball. How many ways can we put it in there? 1 ball can either go here or here. Let's say it goes here. But this box has no balls in it, and it says that at least 1 ball has to be in the box. So this is going to be a 0. And we have 3 boxes, 1 ball. There cannot be at least 1 ball in the box because there's more box than the ball. So this is 0, this is 0, 0, 0, 0, and 0. Okay, and now we have 2 and 0. So we have 0 boxes, 2 balls. There's nothing we can do about it. Okay, and now we have 1 box and 2 balls. How many ways can we put it in there? 2 balls can get in here, and that is at least 1 ball in the box. So there's only 1 way. 2 and 1. And now we have 2 ball and 2 box. That is equal to be 1. So 3 ball, 3 box, 1, 4 ball, 4 box, 1, 1, 1, 1, 1. Okay, and now all of this is 0 because there is more box than the ball. It means not every box is guaranteed to have at least 1 ball. So all of this is 0. Okay, and now we have 3 ball and 0 boxes. 3 ball and 0 boxes. That's just 0. There's no box to begin with. This is also 0. This is also 0. This is also 0. And this is also 0. And this is also 0. Okay, let's fill these 2 in. Okay, there is 1 box and 3 ball. 3. There is only 1 way, which is just all of them going in there. And now we have 3 ball and 2 boxes. So we have 3 ball, 1, 2, 3, and 2 boxes. We actually have multiple boxes now. Okay, so, and it says that the ball is distinguishable. There's a difference. And the box is not distinguishable. They're the same thing. Now, how many ways can we put that in here? So, we can have 0 balls in this box, even though it's the same thing. And we can have 3 balls here. And how many ways is that? That's just 1. Grabbing all 3 of them and putting it here, and none here. And now we can have 1 ball here and 2 ball here. How many ways is that? Grabbing 2 balls from this, we can have the sequence of 1 and 3, 1 and 2, 2 and 3, and that's all. And that is only 3 ways. But it says at least 1 ball in the box. We cannot have the 0, 1. So the answer is equal to 3. That will be it for this video. We will fill them out for others video. So see you there. Bye.